All right. Welcome back, everyone. I promised to do an example problem here, but we're gonna hold off on a little bit. I want to explain a couple more things that are gonna be important to us. And what I did was I redrew our previous drawing here and try to make it a little bit cleaner. One thing I wanted to note here is that one thing that's really important to understand about Mohr circle is that here this represents theta equals 0 degrees. This represents our state of stress here at x prime. I'm sorry, not x prime, but at x here in that original coordinate system that we drew. And here was this sigma x, okay? Sigma x. If we went and here was this tau xy, if you will. So in a way, we're kind of like talking about this face of the stress element. And if I went, if you will, if I go all the way to the other side over here, right? Based on equilibrium, you know that this right here is also sigma x, and this should also be tau xy, right? This right here. So if I go all the way to the other side, which in real life, if you will, this real life, it would be a rotation of 180 degrees, okay? 180 degrees here, but that 180 degrees is essentially going back to the same state of stress. So what that means is 180 in real life is actually 360. It's 360 all the way around back over here. Back to the same state of stress right here. So this location right here. So what that means is that if you rotate theta in real life, okay, real life right here, real life, then it really in Mohr circle, that means 2 theta in Mohr's circle. All right, so that's kind of important to note. Okay, so here if you and you can tell obviously from these equations here, the stress transformation equations, the existence of this 2 theta here, here, and here just implies, again, if you take this into a circle, it just shows that this 2 theta actually does occur, this theta to 2 theta relationship. But and so here, if I want to look at, in particular, things that I'm interested in terms of like principal stresses, so if I want to get to sigma 1 here, I've got to go this angle right here, alpha. Okay, and that angle alpha would just be, in order to calculate that angle alpha, we'd be talking about tangent of alpha is the opposite over the adjacent, tau xy over sigma x minus sigma average, right? And then we would do the inverse tangent and calculate alpha right there, okay? This alpha is some number that's alpha is equal to 2 theta. And if we want to get the theta, it would be alpha divided by 2, okay? So that if I wanted to go to the sigma 1 orientation, if you will, the principal, the maximum principal stress here, this is what we're talking about here is an angle of rotation of alpha over 2 or theta, and we went here, we went counterclockwise. So that means that this original x-axis that was here, we are going to draw this at an angle up here. Here, this angle right here would be alpha over 2 or theta to get to that sigma 1 face, if you will. And then after I draw those lines right there, I'm going to draw a square. I'm going to draw a line perpendicular to that line, and then the remainder of this right here, and this right here, this face right here essentially represents this point. And here I've got sigma 1 going that way at an angle theta, which is equal to alpha over 2. Okay? This alpha over 2, or anyway, okay, so here this is sigma 1, and this is right here, that sigma, that'll be the straight of stress. And then if I want to go to the other side of that, I want to go, if I want to go to the other side of that, if if I want to go to, let's say, sigma 2, if I want to find sigma 2 here, this sigma 2 from this point would be 180 degrees from this sigma 1. So here sigma 1 is here at theta right here. Then I have to go all the way around 180 from this line right here, which would be 90, right, in real life. So if I go 180 and Mohr circle, here is sigma 2 up here. Okay, and so anyway, so this is where the example problem would be helpful. Okay, but if anyways, if we apply this approach to everything, And then same thing with here. If I want to get to the maximum, let's say shear stress at this point right here. So let's call that, let's make that purple right here. So if I want to get to this maximum shear stress here, I'm going to, from my original horizontal axis, I need to go some angle beta, if you will. And that angle is just, I've got here, all I need to do is do this again right here. It's just, well, it's just 90 minus alpha, or beta, tangent beta is equal to, in this case, this is opposite here, which would be sigma x minus sigma average over the the tau x, or the adjacent, so tau xy, it's just a flip, okay, or just 90 degrees, or beta is equal to 90 minus alpha, right? 90 degrees minus alpha, because this is 90 right here. So, hey, great. Life is easy, right? Anyway, so here, and this right here would tell us, hey, if I want to get to the maximum shear stress state from here, I would start with my original here. I had to rotate clockwise an angle of beta, which in Mohr circle, I rotated the angle beta, which means in real life, to get to this maximum in-plane shear stress state, I got to go here. This is beta over 2. Can you even see that? Let's just draw that over here. This is beta over 2, okay? Right? And that means, and then to draw my representative volume element, I'm going to draw a line perpendicular to that purple one, draw the remainder of the square, okay? And that tells me on this face right here, if I zoom in on this, make it really big here, right here. If I zoom in on this right here, bam, bam, right here. I've got some lines. Here was my, if you will, my original x axis, and then here is my new beta over 2 axis here. This is beta over 2. This is my maximum in plane shear stress state, and I have here a plus tau, okay? A plus tau, okay? So this would be my new plus direction, and another new plus direction here. And this would be right here, this would be my tau max on the plus x. This is a positive tau, so it would be this direction, and here this would be my tau max, and I would have here, let's see, an equilibrium, bam, bam, tau max, and then here the normal stresses in this case, this point at C is just sigma average, right? And here this is just sigma average, and it doesn't matter what side I'm on for this maximum shear stress, it's always sigma average. Right, I love more circle. Okay, here we go. All right, so finally, all right, after much explanation of the stuff, we're gonna put some numbers to this, and those of you who are upset, oh, you didn't do the example problem, don't judge me, judge yourself. All right, see you in a little bit.